Hello everyone, I am Harsh Patel, and today I am going to give you the demonstration of my project. This is an end-to-end MLOps project that handles all the stages of machine learning pipeline and perform automatic deployment in the cloud. Let me tell you more about my project. Here is the tech stack that I use for building this project. I utilize Python libraries for performing machine learning tasks, and I use MLflow, data version control, and DAX Hub for implementing my machine learning pipeline. And for deployment purpose, I use Docker, GitHub Actions, and AWS services like EC2 and ECR, and I built the inference app with FastAPI. Here is the demo of my project. As I deployed my project on AWS EC2 machine, I could access it on port 8080 of the public IP address of my EC2 machine. Let me show you how it works. When we input any text and analyze, it will provide us with a sentiment and the confidence score. That's it. All right, here are the key features of my project. Firstly, I have performed various experimentation for choosing the combination of best algorithm and the vectorizer for my project. And here are the algorithms and the vectorizers on which I performed the experimentation with the help of MLflow. And here's my MLflow dashboard. I first built a logistic regression baseline model. Then I performed the experimentation on various algorithms and the vectorizers. And based on the findings, I choose the logistic regression as my algorithm and bag of words as my vectorizer. And I make use of data version control for automating my machine learning pipeline from data ingestion to model building and model registry. And here's the corresponding DVC YAML file. It includes stages like data ingestion, data preprocessing, feature engineering, model building, model evaluation, and at last model registration to MLflow. And I have performed comprehensive testing of my trained model and my FastAPI endpoint. And I also wrote script for automatic model promotion into the production. Here is the corresponding code for the testing of model. Here I tested the input and output shape of the model, and I checked the model performance based on the metrics like accuracy, precision, recall, and F1. And here's the script for the promotion of my model. Here I just directly promoted my latest model into the production by archiving the current model that is in production. Well, we could perform here conditional promotion of the model by utilizing some techniques like A/B testing, differential testing, or shadow testing. And I deployed my project on AWS EC2 machine by implementing the CI/CD pipeline. I have integrated the testing and promotion of my model into the CI/CD pipeline. And here's the project structure that I use for building this project. And here's the DVC pipeline that I implemented for this project. It includes the stages like data ingestion, data preprocessing, feature engineering, model building, model evolution, and model registration. We could rerun this whole pipeline any number of times with a single command, that is DVC repro, and we could push the corresponding artifacts to our object storage that could be AWS S3. And here's the integration diagram that includes the tools that I use for building this project. It includes DVC for data versioning, Git for code versioning, and MLflow for experiment tracking and model registry. And I used DAXHub as my central repository. And here is the CI/CD workflow that I use for building this project. The CI job consists of the running of DVC pipeline, and it performs the unit testing of my model as well as my FastAPI endpoint. And it builds the Docker image and push the image to AWS ECR. Then my EC2 machine, which implements the CD job, pulls the latest image from ECR and run the Docker image as a container. And here are the future enhancements that I plan for this project. Firstly, we could deploy our project on Kubernetes for auto-scaling, and we could perform caching with the help of Redis DB. And I also planned for implementing a proper authentication for our project, and we could also implement a monitoring system with the help of tools like Prometheus and Grafana. Thank you.